let's find slope at C. So second one is slope at C. So what is the slope at C? Theta C, and we need two referential point. I'll call it as theta CE. Theta CE is equal to area of MOEA diagram between A and C. Okay, area of MOEA diagram between A and C. You can write always, no problem, nothing will happen, or else you can directly use the integration method. Theta CE is equal to theta C minus theta E. So theta E is equal to 0, so which is equal to theta C, which is equal to integration mx by EI into dx. Area of MOEA diagram between A and C, between C and E, sorry, C and C, C and E, between C and E, I'm sorry, between C and E. So we need an area between C and E. This area only I want it. So if you use the integration part, so easily you can do it. So what is the integration range? Now integration range is, so it is L by 3 to L by 3 to L by 2. So that is what is the range we have, L by 3 to L by 2, and mx we already discussed, W by 2EI into Lx minus x square into dx. So I will not going to explain everything here. You solve it and you can easily get it. So you will get it. So this is works out to be 37 by 3456 WL cube by EI, WL cube. Okay, if you solve, you will get it. This one is 13 by 648 WL cube by EI, or 0.02006 WL cube by E, anything. Okay, so that's all about the slope. Now let's find the deflection. So let's first find the deflection E. So deflection E. So what is deflection E? Delta E. Delta E is equal to, you can say always, moment of M by EI diagram between A and E about A. So let me recall that. Moment of MOEA diagram between A and E about A, tangent drawn from A and the tangent drawn from A, tangent drawn from E and tangent drawn from A and tangent drawn from E, measured at A. So this is what is delta E, maximum deflection. So that is reason about E. Now if you use the integration concept, I think probably you will get it now. Integration range is 0 to L by 2 mx divided by EI, general I'm saying, into x into dx. Now what is the x here? Mx, there is no change. W by 2 into Lx minus x square. And what is the x? X is x here. There is no change because you're taking the moment. If you look at here, you're taking the moment about A. There is no change. X is x. Wherever it goes, the strip you have moved, it will be x. Now split up this into two regions as we discussed in the previous segment, which is equal to integration 0 to L by 3. So W by 2 into 2 is then, so 4 EI into Lx minus x square into x into dx plus integration. So L by 3 to L by 2 W by 2 EI into Lx minus x square into x into dx. So let's do the integration part, or roughly you can do it. If you want, I can do it here simple way. W by 4 EI is a common, you take it outside. So x you multiply it, L into x square becomes, after doing integration, x cube divided by 3 minus x cube is there, so x to the power 4 divided by 4, so 0 to L by 3 plus integration, you do it here, w by 2 is a common, you take it outside, put it in the integration form. So same here, L into x square is a x cube by 3 minus x cube, it comes x to the power 4 by 4, range you give it L by 3 to L by 2. Now you simplify this one. If you simplify, you will get delta E is equal to 37 by 3456 W L the power 4 by EI, or you can always write is 0.0107 W L the power 4 by EI. Okay, this is what about the delta E. So let's find the delta C now. So okay, so how will find the delta C? So let's find it. You can use the same concept. If you want to try this, will not work out everything, so I'll give the range and I can close it up. If you want, I can share you the answer at the end, so you try to work out. Now delta C, I want the deflection at E. So concept is same. We need a two referential point, C and E. So C dash, C double dash. Okay, then what will happen? Moment of memory C delta C. What is delta C? So now write down deflection at C. Deflection at C. So what is deflection at C? Deflection at C, I can see delta C is equal to C dash. So which is equal to C double dash minus C dash C double dash. What is C double dash or C dash is equal to delta E, which you have calculated it. If I'm recollecting, you can check it out here. C double dash is delta E, which you have calculated. Only thing is you need to find out. So C dash C double dash is moment of M by E diagram between C and E about C. So you need to get it about C. About C. Then you can, okay, let me quickly finish this. It's done already. What is the answer? Integration. So C dash C double dash is equal to, integration range is L by 3 to L by 2. Mx, what is the mx value you will be treating as? So it is a 2EI region, so W by 2EI. So this is the region, W by 2EI into Lx minus x square into x. Now we have a into x is there because moment of memory diagram into x and dx. Now what is the value of x here? So x, where you have to take the moment. Now come back here. Where you have to take the moment? You are taking the moment MOA diagram between about, sorry, C and E about C. So this is the distance. You have wanted to know this distance. X minus L by 3. So this is what you wanted the distance. X minus L by 3, you will get this distance, right? I want this distance. So you know this distance L by 3, you know this distance is x. So x minus L by 3. So x here, x minus L by 3. So substitute here x minus L by 3. So it's very, very important. If you miss, you will not get the proper answer. It's very crucial. Okay, then solve it. If you solve it, you will get 53 by 31104 WL the power 4 by EI. Now if you, now what you want the delta C. So delta C is equal to, so you know the answer, 37 by 3456 WL the power 4 by EI minus 53 divided by 31104 WL the power 4 by EI, and you will get it directly. I can write it in the ratio, or I can say in the form of this one only, answer. So answer is